In this example, we're going to look at the relationship between video games and GPA. So here we had a student at Joliet Junior College that conducted a survey of 20 randomly selected full-time students to determine the relation between the number of hours of video game playing each week, X, and the resulting grade point average, Y. So we are looking at hours of video game playing being your explanatory variable and your response variable GPA. She found that there was a linear relation that it did exist between the two variables, and we can see here that we have our least squares regression line, which I underline in green. First, we want to identify and interpret the slope. In this form, remember, I'm looking for a number that's next to my explanatory variable, in this case, X. We can see next to the equal sign, and remember, that's not how it always happens, but we can see next to the X and the equal sign is this negative 0.0526. So when I want to consider interpreting this, we want to go ahead and set up that relationship of y over x and identify our variables. It just helps us to organize our thoughts so we can come up with a sentence. So we know that slope is the y over x, or response over explanatory. In this case, my y value represents GPA, and X values represent hours gaming per week. As we said in a previous video, I can always take that number representing the slope, the negative 0.0526, and write it over the number 1 without actually changing that value itself. So we might be able to say then negative 0.0526 GPA for 1 hour gaming per week. And that helps us to almost be able to write the sentence just because I put it in that form. So in order to interpret it, I'm going to start with our explanatory variable. For each additional hour a student spends playing video games in a week, the GPA will decrease by 0.0526 points on average. So I have both components or both variables identified in my sentence, the hours spent playing video games as well as your GPA. And then I'm also identifying what variable is increasing and what variable is decreasing. Because my slope is negative here, we're going to say that my X value, the hours of gaming, are increasing, and therefore my GPA must be decreasing. And then, of course, we're going to allow for a little bit of wiggle room there by just kind of putting it as on average. There's another way to also interpret this slope, and that is using this sentence right here. For each additional hour a student spends playing video games in a week, the expected GPA will decrease by 0.0526 points. You'll notice that these two sentences look exactly the same until you get to the comma. After the comma, that's where they've just kind of differed slightly. The first sentence uses the word on average to kind of give you that wiggle room, whereas the second sentence uses this word expected GPA and just kind of restructures the sentence. But both of them are an equivalent way of interpreting slope. Let's move on to now interpreting the y-intercept. Remember that we are looking for in our model up here, in our least squares regression formula, we're looking for a value, any number that's in that equation that's all by itself. And that happens to be this 2.9342. It's a number that's all by itself. It doesn't have a variable that I'm multiplying by it at all. So in order to interpret this, we also need to make sure we understand that we get this 2.9342, we get this y-intercept when the explanatory value x is equal to 0. That means that the mean or average GPA for a student who does not play video games or who plays 0 video games is 2.9342. Now you always want to ask yourself one more time, does it make sense to interpret this y-intercept? Could this be our starting point? And I would say yes, it does make sense for us to have a value starting at 2.9342 because there could be people who play 0 hours of gaming and still have a GPA of 2.9342. Still working with this exact same example on video games and GPAs. Now we want to see if we could predict the GPA for a student who plays 8 hours of games per week. Remember that our least squares regression model does exactly that. It is about predicting your values given some sort of input. It's about predicting what we expect to happen if we have so many hours of gaming per week. So what we're going to look for here is I'm just going to use the formula that was already given to me in the problem, and I'm going to substitute in for X, because remember X is the hours spent gaming. So I'm going to plug in 8 for X and then simplify with my calculator these numbers here, and I find 2.51 is the value I calculated. This means that we have a predicted GPA for a student gaming 8 hours per week to be 2.51. The second question on the screen is a similar process, but we're coming at it, I think, a little bit differently. In this scenario, we have a student who already plays 7 hours per week and her GPA is 2.68. So 7 hours per week with a GPA of 2.68 is what is actually occurring. The next sentence says, is this student's GPA above or below average among all the students who play video games 7 hours per week? In order to figure this out, we need to come up with what we predict the GPA would be for somebody playing 7 hours per week and compare that to the 2.68, which is what's actually happening. So again, using the formula that we started with, we want to predict the GPA for 7 hours. So same formula, this time I'm going to use 7 hours, and I come up with a GPA, a predicted GPA of 2.56. Remember that according to the problem, we already have a student who plays the 7 hours and has an actual GPA of 2.68. In order to determine whether or not this student's GPA is above or below the predicted average, we would subtract the predicted GPA from the actual GPA. So 2.68 minus 2.56 gives me a positive 0.12, and therefore we would be able to say that students' actual GPA from 7 hours of gaming, this student's actual GPA from 7 hours of gaming is above the expected average.